Quem tem uma empresa sabe quanto tempo é valioso. Por isso, a Apex Brasil apoia empresas brasileiras que querem exportar seus produtos, atrair investimentos estrangeiros ou empreender no exterior. Com a Apex Brasil, as empresas brasileiras têm um apoio estratégico para mandar seus produtos e serviços para fora do país de uma forma inteligente e segura. Com métodos inovadores, parcerias, soluções inteligentes, visão de mercado, conteúdos estratégicos e muita qualificação, a Apex Brasil é referência na promoção de exportações, internacionalização de empresas e atração de investimentos estrangeiros. A agência também atua de forma coordenada com atores públicos e privados em setores estratégicos, tanto para o desenvolvimento da competitividade das empresas quanto para o fortalecimento da economia brasileira. Se é conexão com o mundo de oportunidades no mercado internacional que a sua empresa procura, é o apoio da Apex Brasil que ela precisa. Acesse o mundo. Acesse a Apex Brasil. Quem tem uma empresa sabe quanto tempo é valioso. Por isso, a Apex Brasil apoia empresas brasileiras que querem exportar seus produtos, atrair investimentos estrangeiros ou empreender no exterior. Com a Apex Brasil, as empresas brasileiras têm um apoio estratégico para mandar seus produtos e serviços para fora do país de uma forma inteligente e segura. Com métodos inovadores, parcerias, soluções inteligentes, visão de mercado, conteúdos estratégicos e muita qualificação, a Apex Brasil é referência na promoção de exportações, internacionalização de empresas e atração de investimentos estrangeiros. A agência também atua de forma coordenada com atores públicos e privados em setores estratégicos, tanto para o desenvolvimento da competitividade das empresas quanto para o fortalecimento da economia brasileira. Se é conexão com o mundo de oportunidades no mercado internacional que a sua empresa procura, é o apoio da Apex Brasil que ela precisa. Acesse o mundo. Acesse a Apex Brasil.
Good afternoon. I'm Glaucia Souza, coordinator of FAPESP Bioenergy program, Bioen. Thank you for being with us today here. Can I have the first slide, please? The idea of this webinar is to present the next decade plans of the program. Next. We have here with us Professor Rubens Maciel, Professor Luiz Augusto Horta Nogueira, Professor Heitor Cantarella, and Luiz Cassinelli, all members of the Bioen Coordination Committee. This event is cause of much celebration for us here. Bioen is starting a new decade, and we worked very hard to organize a solid set of next steps. I thank all the hands and neurons that participated in this effort, including fellow colleague coordinators, the scientific director of FAPESP, Professor Luiz Melo, and the previous director, Professor Carlos Henrique de Brito Cruz. Next. I'll describe the goals of the program for research related to the Biomass division. Rubens will follow talking about biofuels technologies and biorefineries. Horta will speak about end use, Heitor about sustainability, and Cassinelli about opportunities for research in small businesses. I understand we have many students joining us here, and I think it will be good for you to have a sense of how to start your own business following on your research results and new ideas. Well, I would like to start by saying that bioenergy research is a vast area. So we have a disclaimer here. Bioenergy spreads throughout at least 20 areas of knowledge at FAPESP. So the best we can do in the context of a webinar is to give you some broad strokes, the vision of the forest other than the trees, and stress that if we fail to address some aspect or other, does not mean we are excluding it from the plans. But before we start, I'll give a brief introduction on the status of bioenergy and its importance. Next. Bioenergy is essential globally if we want transition to a sustainable energy matrix without fossil fuels. Bioenergy is also considered essential for a world below 2 degrees. Bioenergy can be leveraged in efforts that aim at sustainable development, helping organize knowledge and establish priorities. As a rising global market, it's bringing partnerships opportunities, and it is an area in acceleration with many countries passing mandates, regulations, certifications, and an increasing number of industries getting involved. Next. It's important to note that the observed gains in efficiency and our ability to work with many different biomass options are expanding the economic, environmental, and social value. We need more research on analyzing the extent of the benefits since they impinge on so many factors of our societies. They are there, but we need the data, we need the numbers. This is an important point here. And I have to observe the growing interest in new forms of bioenergy, including lignocellulosic ethanol, green diesel, aviation, maritime biofuels, and more recently, renewable hydrogen. We are also seeing new byproducts, new biomaterials, not just substitutions. We have new products coming that are derived from biomass. This is under development, and the transformation of refineries in biorefineries is also considered an important fact, considering the immense infrastructure and the funds we have in the world for oil refining. Next. Bioenergy has been a landmark for the state of São Paulo development. São Paulo has the capacity, it has the infrastructure, it has the people to develop technologies along the whole chain. We have mature institutions that can support this. And we have FAPESP. FAPESP articulated many important initiatives in this field. We are at a point where a certain critical mass has been reached, where one thing leads to another, and at least in this field, we have quite a lot of synergy between industry and universities working together to innovate. Next. Bioenergy has undoubtedly contributed to Brazil's largely renewable energy matrix. I think it's next. Yes, thank you. Bioenergy has undoubtedly contributed to Brazil's largely renewable energy matrix. No country with a population of more than 60 million people has an energy matrix with more than 40% of renewables. We have a liquid fuel matrix of 50.2% ethanol, an all-time record announced last year. This is no small feat. With 43% renewables, we are more than twice the global average. We have a potential to generate bioelectricity, which is huge. Being an agricultural country, there is over 1 billion tons of agricultural residues we could use. And we have new legislation in place to use waste for energy. So we are with many more options of biomass to develop in this country. With bagasse, we are making 17% of our electricity already. All of this has been achieved with using not a lot of land, 7% of our agricultural land, with avoided emissions in 20 years that correspond to 4 billion trees. Next. If we continue this trajectory of substitution of fossil fuels with biomass, São Paulo could be negative emissions. There are several advantages of biomass over other resources, and it can be used to combine with other resources. Biomass can be stored. It uses local resources, it can use existing infrastructure, it can bring wealth to rural regions, and it is compatible with electric cars that can make the use of bioenergy even more efficient. All of these vehicle models on the bottom of the slide are already in production or being commercialized. We go from 257 grams of CO2 equivalent per kilometer using a gasoline vehicle, to 122 in a hybrid running on gasoline, to 117 in a car running on 100% ethanol, to 92 in the case of the EU electric vehicles, to 59 of a hybrid that can use ethanol, and 29 in an electric car with fuel cells that can use ethanol. Much better than the plug-ins. A lot of potential to improve our fleet in the way of a more sustainable fleet. Next. Well, back to the Bioen program. Here are the cross-cutting issues that we would like to pursue in the next decade. Increase biomass yields. develop efficient and competitive biomass conversion platforms, improve energy efficiency and sustainability of end use, accelerate the transition to a bioeconomy. We want to broaden and diversify. Next. We will continue to work on reinforcing ties with the industry and scientific institutions. Next. For example, with the organization every 3 years of the Brazilian Bioenergy Science and Technology Conference, BBEST, which we organize since 2011 and which gathers researchers, policymakers, government and non-government organizations, so many students, postdocs. It's a very lively meeting. Next. Bioen has an internal agenda to organize conferences, workshops, work groups, activities for knowledge dissemination and calls for projects. We have a market agenda to seek partners and fund initiatives in small businesses or with large companies, such as the programs of technology innovation and programs in small business, the PPs, the large centers for engineering research. We have an international agenda. We are currently giving support to Scope, IPCC, Renova Bio, and we have a policy agenda where we work with the IEA Bioenergy Task Force, the Biofuture Platform, and GBEP. Next. Since 2009, we have funded 305 research projects, 188 startup companies, and 711 fellowships. A lot of the results you can find today in the video posters being presented by 498 researchers from 98 institutions during this virtual conference and next May in the hybrid BBEST Biofuture Conference that we are planning. Next. And now I'd like to go quickly over the specific goals of the biomass division of the Bioen program. Next. The idea is to increase and diversify both on the biomass end and the final products. We seek research that can lead to improved yields of many feedstocks. We want bioenergy, bioproducts, and carbon capture. We want to understand what are the mechanics that underline efficient use of resources and future climate resilience. We want to address drought, stresses, and use of nitrogen. Note that there are many areas that must come together for us to achieve these goals. This is very ambitious. We need biotechnology, breeding, genomics, metabolic engineering, and genetics, for instance. We have a large community that is already working on these fronts and many collaborators in many countries across the globe. Next. The same is true if we want to address the agronomical restrictions. We have to combine agronomy, biophysics, biochemistry, hydrology, ecology, economics, and so on. We have some very interesting results that say that if we expand bioenergy into pasture lands, there are many gains on the sustainability front. So we need more research on that. But it is a long list that we wish that we hope you can later on look in our website. We are going to publish the whole plan. Next. This is just to illustrate, to summarize what I've been meaning. The current low yields of many crops of interest for bioenergy illustrate these points. We are currently, if you look at the right bar, the bar on the right, we are currently working to prevent losses, dealing with the agronomic constraints. That's why we have lower yields than we would like. We need to address the environmental constraints. And if we want to reach the expected potential, which is much, much larger for many crops that we are growing, we need to change plant physiology, architecture, crop characteristics, which is what the breeding programs are doing. We need to bring them more tools towards this end. We are now approaching the point of being able to perhaps increase our expectations of how far we can go with genetics. We have now genome sequenced, we can potentially edit these genomes. We have systems and synthetic biology approaches underway. We believe that we will see even further increases in yields in the next decade. So with that, I finish. We have now to discuss the research expected for the other divisions of the Bioen program. Thank you very much. Well, thank you all for being here. I'm here with our colleague coordinators of the Bioen program, Professor Rubens, Luiz Horta, Luiz Fernando Cassinelli, and Heitor Cantarella. I'd like to give the word to Professor Rubens, who will speak about the goals of the Biofuels Technologies Division and Biorefineries.
Biofuels are an important part of the Bioen program, and we would like now to point out some of the advances and the activities that you have in the program. Next slide, please. Next one. So some specific goals of biofuels cover a very broad range of activities. Once you have several types of biofuels, one for light vehicles, like as ethanol and the biobutanol, and the heavy fuels, cars as powered by diesel cycle engines. Then we have biodiesel co-processing and the additives for using of ethanol as a fuel for biodiesel engines. We have hydrogen as a fuel, and in this case, the ethanol can be a hydrogen carriers to avoid high pressures tanks in the cars, so onboard technologies to use production of hydrogen in the cars. You have biofuels and marine fuels as well. Next one, please. So with this very broad range of biofuels, and our focus is to increase the biofuel production in terms of process development and the process improvement. Brazil is a top country in the biofuel production, and the most important example is ethanol. Even that it's a very well consolidated process, there is a window of opportunities to improve the process, either to reduce the cost or to increase the potential for the use of biomass. And then we can expand this idea to biodiesel too, and for biofuels as jet fuel, marine fuel as well. The point is to improve the productivity of the biofuel production. We have to take into account the importance of the biomass use, because it is the feedstock of the process to produce biofuels. And then a large, broad number of options are at our hands to use the conversion process. And the feedstock are increasingly always increasing the amount of opportunities. So we have in Brazilian case eucalyptus, sugarcane, soybean, agricultural residues, and even municipal waste residues. So, and then it's quite important to take into account the whole production process, some kind of system integrations in such way that production, conversion, and use of biomass can be made in a quite reasonable way to decrease the cost and to increase the productivity of the process itself. Among the options, the densification of biomass is a quite an important topic because it means that you can transport. You have a supply chain much more in clever ways to use well the biomass and impact the costs in the sustainability costs of the whole system. Also, storage plays a quite important role once you have to increase the expansion or to increase the operation period of the plants. And then in the case of sugarcane, for instance, we are running nowadays with about 200 days a year, and then there is a lot of options to improve the process itself, not only by day operation, but also increase the period of operation of these plants. The pre-processing, including technical economic evaluation, is a quite important point that you have to take into account the whole process. Once we are talking about the conversion itself, depend on the quality of the raw material, feedstock, and this come from the agricultural point of view, but you have to do some pre-processing before using it and also transporting it. So pelleting, torrefaction, drying, for instance, are some of these possible operations that you may use to include as a pre-processing activity. And then you have to do the techno-economic evaluation to bring to have some idea and to bring it to the knowledge how much does it cost compared to with another options. So that's a quite important point. Once the biomass itself is responsible and the logistics of it is more or less 70% of the total cost in average of the biofuels. Process flexibility for multi-biomass in the moisture is also a hot topic. Why? Because this means that you may use more than one feedstock and then with different process conditions to run the plant and to obtain product to match the specification, but using a large options of possible feedstock. And then we have specific points as a microreactor catalysts and downstream processing, that's separation. That's quite important, for instance, when you are talking about using ethanol as a hydrogen carrier on onboard technology to provide hydrogen for fuel cells and the electrification of light cars or to have good cars. That's a point that is going to be covered in next part of end use of Bioen. Next slide, please. With all this that I have mentioned, the general methodology of the evaluation takes into account the techno-economic evaluation as well as the life cycle analysis and the social impact of the whole process. This whole process means then that you have to collect your biomass as agriculture site, and then you have to do a pre-processing, that's the next part of the process, in which you have one intermediate product that can be used for the industrial part of the process to produce the biofuels itself, or it can be sold to another company to produce the biofuels. So that's the part of the process. And then when it comes to be used in the industrial side, you have a large, again, possible options that can be used, and then you have to do techno-economic evaluation, sustainability analysis to see what is the best or the most appropriate conversion technology for that special crop or for that special feedstock that you have, or a mixture of this feedstock that can be, for instance, sugarcane, sugarcane stover, corn stover, and so on. And then we have to match this industrial process with the quality of the product that the society requires to use as a biofuel, for instance. And then you have flammability point, vapor pressure, and a lot of octane index, a lot of index that you have to match to attend its requirements. And then the interesting point about that is you have to, again, to rethink about it. Which is the best feedstock, which is the best conversion technology that I can use to match all these points that I have mentioned. Next slide, please. And then this comes to the biorefinery. It's another topic of the Bioen program that's quite important, and it's complete in some way the biofuels sector of the program, as it is in the oil industries. Next one, please. And then the biorefinery itself has intention focused on development efficient and competitive biomass conversion platforms to produce high added value chemicals as well as conventional chemicals. And then we are together with the advanced biofuels technology and bioproducts or bio-based products that can be used for the further processing as polymer or chemicals. So technologies for carbon sequestration and use of carbon, that means that the carbon is not only to be sequestrated, but also is going to be a feedstock for our process. And then we have several conversion platforms that can talk together, can be used together to enhance the possibilities and the conversion technologies and the costs and the final end of the product to match the specifications. We have to think about plants, algae, microorganisms all together sometimes to develop a process that can attend or can, let's say, match some specifications for specific use like in the health area. And then sugar conversion, syngas conversion, methane use, biofuels, hydrogen, polymers, chemicals, building block acids, building block molecules, all of them are part of the investigations that becomes the biorefinery a broader world of opportunity to better use the biomass to advance in terms of new chemicals and new products to attend the society. To reduce technology uncertainty for industrial applications is for sure one point that makes the research very attractive and needed to the development of the country, of the society itself. Next, please. And then just to summarize some of these two next slides, the biochemical platform and the what you say thermochemical platform. Biochemical platform we use the pretreatment, the hydrolysis, and go to the fermentation to get your bioproducts. That is we call the second generation biochemical route. And in the thermochemical platform, you do gasification. And then clean up the gas and go to catalytic conversion, for instance, to go to bioproducts. And then there is a possibility to have a hybrid approach in which you can use the gasification to go straight away to fermentation higher than to go to the conversion catalytically. And then this is together, of course, with the first generation that is sugar extract from, for instance, sugar cane or sugar-rich crops go to the fermentation. And there is also the thermocatalytic route in which you can use thermal plus catalytic to convert biomass in useful chemicals. Next one, please. Just to summarize them, we have a large options to do the biomass conversion to get to the first generation that I put in the first line. And then you go to the second generation that is already on in Brazil. We have 2 or 3 plants already running. Using the sugarcane bagasse as feedstock. We have the gasification that opens a large range of options with the syngas production, and then you go to Fischer-Tropsch and the correlated process to go to produce biofuels and biochemicals. You go to the, let's say, production of bio-oil that is, it allows you to do the co-processing and or further process using thermocatalytic roads to produce or to use this bio as a feedstock, the biofuels and the bio-based products. You have the gasification also that is possible to do this lots of things We have to biogas generation that can go to methane, and then you can methane to other products. And then before you can sometimes depend on the biomass, do the pre-extraction, extract some valuable products of that, and then later on go to these large options of conventional technologies. Transit certification, I didn't put in the diagram, but it's just mentioned there. And certification for biodiesel production is also very intense in the biofuels area, but also in the biorefinery to give it add values to the fatty acids and to provide maybe some materials for the food and for the cosmetic area. So biofuels and the biorefinery, they are together in terms of the process and the process improvement with focusing on the better use of the biomass and to take advantage that Brazil has a very strong agribusiness action, and then we have technology to provide or to add value to this agro-based products. Next, please. That's the end for the biofuels and the biorefinery section.
Thank you very much, Rubens. I would like to invite now Professor Horta to talk about the goals of the division of end use.
Thanks, Glaucia. Let's to talk about the final stage of the bioenergy chain, from the solar energy towards the final use. Next slide, please. As you know, we have at least three stages. No? First one is the production of biomass from solar radiation by the photosynthesis process. The second one is the conversion of the biomass as a feedstock in several different types of technologies to produce energy carriers. And the third stage, the last one, is the end use, when these energy carriers is converted in some kind of movement, light, power. It depends what you need. Okay, the next slide, please. So the specific goals that we think that are the priorities to push the development of sustainable bioenergy will be presented briefly in the next slides. Next slide, please. So it's interesting to recognize that there are very different technologies to use biomass to produce some kind of final use. Sometimes using the same equipment, sometimes needing some adaptation, new technologies. I am going to present the main alternatives in 5 lines of technology development. The first one is the biofuel application internal combustion engines. Using the conventional technology in the motors, there are a lot of possibilities to improve the use of bioenergy. The second one is the ethanol application in electrical vehicles. There is a rising number of alternative in this case. The third one is the sustainable aviation biofuels or fuels based on biomass. It's interesting also to comment what could be our priority on that. The fourth one is the marine and stationary application of biofuels. And the last one is the power production, electricity production using bioenergy. So the next slide, please. So it's interesting to mention, to stress that sometimes appear that the internal combustion engine is in the end of this era. Now it's time of the electric motor. It's not absolutely true, because chemical energy in fuels is an important source of energy and will remain in use for many decades ahead. So we think that at least 4 lines should be considered: the improvement of Otto cycles engines for ethanol. The case of the variable compression ratio is the Nissan model this picture is showing is a very interesting option to take more energy from ethanol due to the advantages of ethanol compared with other hydrocarbons such as gasoline. So it's possible using compression variation to reach this. The second model in this picture is the model developed by Fiat Chrysler Automotive, and will be in the market in the forthcoming years. It's very interesting also using electrical compression. It starts with a Brazilian patent, and it is now to be produced, planned to be produced in the next years, also recovering more energy per energy content in the ethanol compared with gasoline. So there are examples of this kind of new technology that should be improved and promoted. So the second one is the advanced flexible fuel engines that are able to burn both. As you know, the flex fuel are able to burn gasoline and ethanol. And this is the case of this FCA E4 is more for ethanol, but the Nissan variable compression is able to burn different kinds of fuels and using the high octane number of ethanol compared with gasoline. The third and the fourth one are related to diesel engines. There are possibilities to use ethanol in the diesel engines. There are experience, there are some projects in that, and also considering improvements specifically dealing with the proper features and characteristics and specifications of biodiesel and HVO. Next slide, please. Here we have the concepts more associated to use of ethanol in electric vehicles. As you know, electric vehicles are vehicles that are moved using electric motors driving the wheels. It's not necessarily connected to the grid. You are using batteries. For instance, in the hybrid vehicles, you can use engines to produce electricity associated with battery to improve efficiency, but it's the case of the Toyota Corolla, which is in production since last year in Brazil, and with good result. It is the most efficient vehicle in terms of emission reduction. This level, about 20 grams of CO2 per kilometer, is the lowest among all cars available today. They are using in this technology the lowest emission fuel, which is the ethanol, associated to the most efficient cycle, which is the hybrid cycle. But there are other opportunities as using ethanol to produce hydrogen. Hydrogen has a lot of advantage compared with electricity from the grid. But hydrogen can be produced from electricity using the electrolysis of water or by ethanol catalytic reform. That could be an interesting opportunity. And as is shown in this graph, in many cases, it is more competitive, it's more interesting to produce ethanol from, produce hydrogen from ethanol. No? This car below is the Mirai from Toyota, is an interesting model that are prepared to use hydrogen, but in this case, hydrogen from the gas station. We can produce ethanol produce hydrogen in the car. The next slide, please. Will help me to show you what I mean. Here you have two ways to supply hydrogen to cars, to mobility. The first one are using a kind of fuel cell using hydrogen, but this hydrogen is produced on board by this scheme, the catalytic reform of ethanol. No? And the second one is the Hydron, is a Brazilian startup company that are able to produce hydrogen from ethanol in stationary unities and compress it for use in vehicles. No? And there is also a third option, which is the direct ethanol fuel cells electrical vehicles that are in the study and development. We think that is an interesting option and should be promoted and should be studied and should be assessed. The next slide, please. This next slide, next is missing the, oh, here. Okay, thanks. It's about the application of biofuels in aviation. It's interesting, maybe it's not so acknowledged by the people, the fact that we are using ethanol in airplanes since the 80s in Brazil. There are 10,000 and more airplanes, small planes, agricultural airplanes using ethanol. But now there is a growing interest in more wide application in jet fuel. Is the called sustainable aviation fuels made by biomass. And there is already an specification. This is considered a drop-in that could be used and blended with a jet fuel, the regular jet fuel, without problems. The process are already certified. And there is an international agreement, the CORSIA, which is the Carbon Offsetting and Reduction Scheme for international aviation, which is in place, progressively advancing, and it is very interesting to pursue, to go towards development and the diffusion and the impacts and the consequences of this. It is an interesting topic for studies in a country as Brazil, for instance. No, we have a large territory. There are many applications of this. And the third one, the next one, please, which is the marine and stationary applications of biofuels. It is interesting. It is a new frontiers. The fuels used in this kind of applications typically are diesel or low quality fuels, but due to some environmental constraints and restrictions, there is a growing interest and opportunity that should be developed and promoted to use biofuels, this kind of application. The next one, please. This slide is the last application, the last but not least application of biomass. It is the application for power production. We have a lot of different materials. Typically, they are byproducts from agro-industry, refuse, municipal residues that could be used to produce powers in competitive conditions with good and important environmental consequences. And in the case of some landfill biogas, the case of using the residues of sugarcane processing, the case of vinasse, the case of different materials, and the pulp and paper industry, but not only using residues, also using dedicated production of forestry and biomass to produce power. In Brazil nowadays, we have the same capacity that you have in Itaipu, our biggest dam for hydropower production. We have 15,400 megawatts, 15,400 megawatts, which means about 90% of the Brazilian capacity. The same approach could be used in other tropical countries with similar conditions to Brazil. So they have a large potential, still untapped, to be developed. So those are our opportunities, a wide set of opportunities to use the bioenergy to supply energy at the final use needs. Thanks.
Thank you, Horta. It was very interesting to see so many options available and in development. I'd like to now give the word to Professor Heitor Cantarella that will discuss the sustainability division goals.
Thank you, Glaucia. Today we are going to talk about sustainability and impacts in the context of the transition to bioeconomy. Next slide, please. In the first 10 years of Bioen, we focused on bioenergy, and now we are going to focus on bioenergy and the bioeconomy. It's a broader scope. The transition from fossil energy in economy to bioeconomy has already started in several countries, including in Brazil. Sustainability is a key aspect of this transition because we need reliable and proven and verifiable indicators of sustainability to foster the bioeconomy. Next slide, please. Well, sustainability has three pillars: economic, social, and environmental. And let's start with the economic pillar of sustainability. To have good technological solutions is not enough. Bioenergy and bioproducts must be economical. So the Bioen program stimulates studies in economic sustainability, including economic models, modeling technologies, changes, financing mechanism, infrastructure, markets, including not only national market but international market, political links needed for markets, regulatory frameworks for sustainability. This is in the national context. For instance, RenovaBio is a good example, and also we have to pay attention also in the international standards. And the interdependencies in the economical materials, energy, and economic areas. Therefore, economy is a very important pillar in the sustainability of bioenergy. Next slide, please. Well, the second pillar of sustainability is the social pillar. Any new or expanding activity has social implications, negative or positive. And this is not different from with the bioeconomy. Therefore, the Bioen program stimulates research in social sciences, including sustainability issues, jobs and new skills. We need data on job creation, job equality, gender equality, and diversity in the context of bioenergy and the bioeconomy. We need also data on advances of industry and agriculture 4.0 and how this will affect job creation, job quality, and qualification. Education resources is an important aspect as well. And we need investigations also in policies, both national and regional, and also in governance. And I must make a point here that at Bioen we lack scientists working on social sciences and issues relating to bioenergy and the bioeconomy. Therefore, Bioen wants to stimulate and attract new talents in this area to work in the Bioen program. Next slide, please. The third pillar is the environmental. I'd say that this is the most important subject internationally because of concerns with global warming, deforestation, loss of biodiversity. Because of these issues, we must keep a close look at all environmental aspects of bioenergy and the bioeconomy. Therefore, the Bioen program is stimulating research on land use change. Land use change is a key international subject in sustainability of bioenergy because we have to see how the expansion of biofuels and feedstock production, crops, and other biomasses affect other land uses, ecosystem services, biodiversity, etc. So life cycle analysis of biofuels and bioproducts is fundamental to tackle these environmental issues. We must have environmental sustainability indicators We must pay attention to water quality and quantity, biodiversity, both the short and long-term effects, air quality, and I'd like to point out here also soil quality and soil sea storage. There's more carbon stored in the soil than in the air, and we see all the consequences of a small changes in CO2 concentration in atmosphere, and there's much more carbon in the soil. So when we play with the soil, we change land use change, we may have effect increasing the amounts of CO2 sent to the atmosphere, as well as the amount of CO2 that will be absorbed by the soil, retained by the soil. So the soils are both sources and sink of CO2. And so we need research on this area to see how we can use the soil appropriately to increase production and at the same time store carbon. The next slide, please. Also of interest in the Bioen program is investigation on CO2 emission associated with co-products and byproducts, nitric oxide emission in bioenergy system. And then here again, I'd like to call attention to this point. About 30 to 50% of the greenhouse gas emitted to produce ethanol in Brazil, for instance, comes from the use of nitrogen fertilizer. For each kilogram of nitrogen applied in the field, 10 kilograms of CO2 equivalent are emitted. Therefore, measurements of greenhouse gases and ways to improve fertilization practices are of great importance to reduce the impact of fertilization on bioenergy and bioproducts in general. We want to stimulate also research on global land data and monitoring systems, developing agroecological chains and local distribution system, and also integrated bioenergy systems for forests, agroforests. As forest products are very important feedstocks for both bioenergy and bioproducts, this is a subject of great interest. And I must say that in Bioen, the first phase of Bioen, we overlooked the issues of forest. But now in the second phase, we want to stimulate particularly research on the use of forest biomass to produce bioenergy. Next slide, please. Wastes and recycling. There is enormous potential in research on waste and recycling. In the second phase of Bioen, we want to stimulate investigation on this subject. We want to develop technologies for the use of agricultural residues, municipal solid wastes, sludge, water and nutrient reuse and recycling in bioenergy systems. We want also to investigate the impact of biogas and biomass-based power plants, among other things. And I'd like to call attention here again to the fact that bioenergy, the bioenergy is stored, or the energy of stored in wastes is very important. Because the organic molecules of waste have energy, embedded energy, the same ways as soybean grains or sugarcane that are used as feedstock for bioenergy. Therefore, we can use wastes to produce bioenergy and bioproducts, and this has many benefits, including environmental and the promotion of a circular economy. And here in the slide we have examples of biogas being produced with municipal solid wastes, biogas being produced from vinasse, and heat and power being produced with wooden wastes. Therefore, this is a large area of investigation that we want to promote Bioen in the next phase. Next slide, please. The other one, please. Next. Okay, thank you. Well, finalizing, we have lots of data available showing that Brazil already has great sustainability indicators for bioenergy. And we can also lead in other sectors of the bioeconomy sector, such as bioproducts and others. Why? Well, we have a competitive industry. We have land and biomass resource to expand bioenergy and to be a leader in the bioeconomy. We have an active scientific community. And Bioen sees that research on sustainability and impacts is fundamental to keep Brazil, to maintain Brazil as in a leading position in bioenergy and to be a leader also in the bioeconomy. So thank you for your attention, and I hand over again to Glaucia. Thank you.
Thank you very much, Heitor. I will call now for Luiz Cassinelli to present opportunities for funding of small businesses and other cooperation with the industry.
Thank you, Glaucia. I will present the opportunities offered for São Paulo Research Foundation to finance projects. Next slide, please. Next one, please. Next one. More one. Yeah, it's okay. It is one of the main agencies for promoting scientific and technological research in Brazil. São Paulo Research Foundation is linked to São Paulo State Economic Development Secretariat. Next slide, please. Innovation Research in Small Business Program was created in 1997, and it's designed to support the execution of scientific and technological research in small companies. The objectives of these programs are support research in science and technology as an instrument to promote technological innovation, promote business development, and increase the competitiveness of small companies. Small companies means companies with up to 250 employees. Create conditions to increase the contribution of research for enhancing the economic and social development, induce and increase in private investments in technological research, enable small companies to associate with researchers from the academic environmental through research projects aimed at technological innovation. Contribute to the formation and development of technological development centers in small companies and to the placement of researchers in the business job market. The main requirements for companies and projects are summarized in the slide shown. Next slide, please. The project evaluation will be done for more than one external consultant with high knowledge in the subject. The rule changed recently, and now it permits the submission throughout the year. Next slide, please. The main points that proponents should pay attention are: the group must have knowledge, but it is not required master or doctor degree. The responsibility for the project must dedicate more than 24 hours per week. The project's phase 2 and phase 2.5 require a business plan and implementation timeline. If a third party shows a formal interest in the project with a financial investment, is considered a positive point for approval success. Next slide, please. The research proposal submitted to this program are organizing into four phases. Phase 1, technical scientific feasibility analysis. Phase 2, directly and indirectly develop of a bench product. Phase 2.5, accelerating the arrival of phase 2 projects to the marketing when there is a third interested party. Phase 3, commercial and industrial development of products, process, system, and/or services. The funds to finance this phase must be obtained from other institutions, such as Desenvolve São Paulo, the National Bank for Economic and Social Development, BNDES, and the Financer of Study and Projects, FINEP. The projects that were financed by innovation researchers in small business program have the technical assessment pre-approved in the case of request for funds at São Paulo State Financing Agency, Desenvolve São Paulo. Small business program, phase 1. I will describe now, I will talk about the details of this phase. Phase 1, with an expected duration of up to 9 months, as intend to carry out research on the technical feasibility of the proposed research. The maximum financing amount foreseen for phase 1 is 200,000 reais, considering all items granted by São Paulo Research Foundation, including technical training, scholarship, and small business research scholarship, except complementary benefits and portion for directly infrastructure costs and of the project. At the end of 9 months, the responsible researcher must submit a final scientific report for phase 1 and the accountability of the research invested by São Paulo Research Foundation. If there is interest in submitting the proposal to receive funding in phase 2, a scientific progress report may be submitted from the 60 months of phase 1 onwards. This scientific progress report is in additional to the final scientific report for phase 1, which should be presented in any way after the end of phase 1 on the date established by São Paulo Research Foundation. The quality of the results presented in the progress report will be decisive for the qualification for phase 2 of the program. Now I will talk about phase 2. Phase 2 is for projects that were supported by São Paulo Research Foundation in phase 1, and those interested in submitting the proposal to receive funding in phase 2. This is the indirect phase 2 that I am talking. Direct phase 2. Those interested in supporting research can be submitted the research proposal directly to phase 2 of the program. In this case, a detailed justification for the no need for phase 1 must be presented, with a detailed description of previous research results related to the proposal in question, clearly demonstrating that phase 1 has already been carried out. Phase 2, directly and indirectly, is expected to last up to 24 months, intended for the development, of the research proposal itself or generation of a pilot sample. The maximum financing amount foreseen for phase 2 is up to R$1 million, considering all items granted by São Paulo Foundation, including the Technical Training Scholarship and the Small Business Research Scholarship, except for complementary benefits and portion for direct infrastructure projects costs. The concession can be made for projects that have demonstrated success in phase 1, and the evaluation will give priority to proposals that documents commitment to financial support from any source for the development of phase 3, or partners active in the market where the product will be sold. In order to receive financing for phase 2, the small company will also have to present a business plan for the commercialization of new products, process, system, and/or services, and describing how the company will obtain the necessary funding for this. Over up to 24 months of phase 2, the company must develop and demonstrate to São Paulo Research Foundation throughout scientific reports the efforts for development of production, commercialization, and financing indispensable for entering phase 3. Innovative Small Business Program Phase 2.5. Phase 2.5 of Innovative Research in Small Business Program is a new modality. Launched in October 2020, last month, aims to offer supplementary funds for PIPE Phase 2 projects which have proven success to accelerate the process of commercialization, the innovation developed through the project, demonstrate the ability to attract private investment from a third party, focus on the technological and commercial development of the product, process, system, and/or services resulting from the research funded by São Paulo Research Foundation are eligible. To be eligible for financing under Innovative Research in Small Business Program Phase 2.5, the small company must demonstrate a private financial investment from independent third party above R$100,000. In this case, the small company may submit a proposal to FAPESP with a budget limited to the same private amount raised, obeying the ceiling of R$1 million. If the small company demonstrates a private financial investment from a third party of 100,000 to 500,000, São Paulo Research Foundation may grant phase 2.5 with a term of up to 12 months for the research continuity. If demonstrate a private financial investment by an independent third party from 400,000 and 1 million, São Paulo Research Foundation may grant phase 2.5 with a term up to 24 months for the continuity of the research. São Paulo Research Foundation will contribute with an amount equal to that contributed by the third party. Phase 3. In phase 3, the small company is expected to internally carry out the commercial and industrial development of products, process, system, and/or innovative services obtained from previous research carried out by the company without the support of São Paulo Research Foundation, or from research support within the scope of this program. The research for phase 3 must be obtained by the small companies from the market, from the other financing agencies, as previously mentioned. The demonstration of concrete perspectives for the financing of phase 3 is considering a positive element in the evaluation of proposals for phase 1 and 2. Next slide, please. Partnership research for technological innovation is another kind of finance line. The research support program is in partnership for technological innovation is intended to finance research projects in higher education and research institutions, public or private in the state of São Paulo, developed in cooperation with researchers from companies, research centers located in Brazil or abroad, and co-financed by them. The program aims to intensify the relationship between higher education and research institutions and companies throughout cooperative and co-financed research projects. São Paulo Research Foundation finances research at the university or institute on non-refundable basis from 20 to 70%. Company contribute to counterpart. This modality has existed since 2006, and several companies of different size and different kind of business already benefited from this type of financing. Now, another kind of line of financing. Engineer Research Center is another one. São Paulo Research Foundation created the special program named Research, Innovation, and Dissemination Centers that supports long-term research projects to focus on problem solving. These centers should count on the participation of companies or government entities that are directly linked to society. The São Paulo Research Foundation program of engineering research centers uses the successful model of the special program research, innovation, and dissemination centers and associate with research in partnership for technological innovation shown previously, in which there is a company research co-financing partner, which propose to actively participate in research projects and use the results obtained with the center. The center's plan should develop from the core of internationally competitive research, effective means of technology transfer, education, and knowledge dissemination. The research for the development of the engineer centers will be allocated in the following proportion: 25% for company, 25% for São Paulo Research Foundation, and 50% for host institution. In any modality of financing, São Paulo State Foundation and companies jointly define the refund amount in the project is successful. The amount returned can be at most total amount financed. More details about this can be found in São Paulo Research Foundation site www.fapesp.br. Thank you.
Thank you, Cassinelli. We now open for questions from the audience. I want to note, yes, okay, we are all back here. We start the Q&A session. I want to note that everyone can pose a question on the Hoover platform. Go to the Q&A on the session. We have a couple of questions for each of us, and I'm glad that we have enough time. So I'll start by answering one question for me. Is there any database or website in where we can have access to some of those data reported in your presentation? Yes, so several points here. After this session, we are going to make available all the slides that we presented here through the Hoover platform as a handout. Okay, so you're gonna have the PDFs of our slides. I suggest you also go to the program website, bioenfapesp.org, and look at the goals of the program, which we published there, the goals for the next decade, and also to the link for publications. There we put several recent publications and reports where we gather the numbers, the statistics of production of bioenergy in Brazil, for reports with the International Energy Agency. And we also have lots of interesting numbers available from the scope report. Another question that was put here is regarding databases. We have an interest in developing a database that can be used for many different projects for the next decade. We're starting to look exactly what we would like to have there. This is work in progress, but I think this is an important point. We do need a central database where people can find life cycle inventories, can find data on land use, on sustainability aspects. So we are certainly aware of the need to develop this. We want to have a synthesis database for the program. I also want to note that we have a database that is publicly available for all the genomics data, bioinformatics tools, to data mine transcriptome data, metabolomics data. We give support to over 20 labs that are working on sugarcane genomics under the program, with many different challenges to sugarcane in field, in greenhouse conditions, with many different stresses. So it's a very useful depository. The other question is if I can comment on cooperations with other countries that cultivate bioenergy crops, since they can benefit from Bioen advances in biofuels. Yeah, so FAPESP has many agreements of cooperation with many countries that work on bioeconomy, on bioenergy. We have, over the last decade, several calls with UK foundations, BBSRC, UK Research Council, would be basic from the Netherlands, with Oak Ridge National Laboratories. We have a cooperation with them. FAPESP has a program that's called Sprint, that funds short trips and exchange of researchers to existing projects in both sides. And we also give support, as I mentioned, to the International Energy Agency Task 39 and Task 45. Task 39 is on commercialization of biofuels, and Task 45 is on sustainability in the context of a bioeconomy. There are many countries involved in this effort, and in the bioenfapesp.org website, you see our publications. We also had cooperations with IRENA that worked to analyze countries in Africa and the Caribbean. And we have a current project to analyze emerging markets. It's 20 emerging markets that the Bioen program is analyzing to see what is the potential of bioenergy expansion, the pathways, and what are the sustainability indicators that we can use to analyze and see the prospects of these endeavors in these countries. So I will follow now with questions for Heitor Cantarella. We have two questions for you, Heitor. The first one, you mentioned that 1 kilogram of nitrogen used as fertilizer generates the equivalent of 10 kilos of CO2. Can you comment on strategies that are being used to reduce this impact? I think you need to unmute. Heitor is still on mute. No? Okay, so let's go into questions while we solve this. Let's go and see if we can hear Rubens. Can you hear me? Can you come up on screen? Rubens is Can you, okay, I see all of you here. Can we do a general test? Can everybody speak now?
Hear me? Hello?
Yes? Okay, Horta. Okay, so my question
I'm
goes for
here.
you now. We come back afterwards to see if Heitor is alive again. Yeah, I still don't hear you, Heitor. Sorry, everyone. We go to Horta. Okay, we have several questions here for Horta. First, what advice would you give to an undergrad student? So this would be master PhD students that are interested in development of technologies in the ethanol hydrogen interface.
Can you make the other questions?
Yes, so I'll read all of them. Okay. The second question. Many European countries are heavily betting on hydrogen with electrolysis from wind and solar energy, where they have a technology advantage, albeit high costs. Besides ethanol, are there other bioenergy sources that could be used to make cheaper hydrogen? So that was the second question, cheaper hydrogen.
Yeah.
Then the next, I have another question. The other question, do you think that biodiesel will be fastly changed by electricity into, I would say, fastly changed into electricity in cars and buses fleet, for instance? So biodiesel substitution by electricity. Okay, you have the word.
Thank you, Glaucia. Thank you for those questions. It's really interesting. And as you can see, hydrogen is on the table. No, you are now discussing and exploring and fascinated with the potential of hydrogen. Hydrogen presents two interesting advantages compared with electricity. The conversion in fuel cells can be done on board with advantages, and the filling up of the vehicles on the gas stations is very more simple and fast compared with electricity, which requires requires more time, and the cost of batteries, the problem of battery. Well, we have also problems carrying compressed hydrogen in very high pressures, 700 atmospheres. Anyway, I believe that in the same way that electricity are coming to stay, is natural to accept that the electrical vehicles are in our future. We have a lot of advantages associating electronics and a kind of motors that doesn't need box of changing the velocities. The load curve of this electrical motor is far better compared with the engine. But the point is, where is the source of this electricity in the electrical vehicles? Probably will not the grid. That is the question, no? So thanks for the question. And the first question is regarding ethanol. The student are a good question, no? What could be interesting topics to study on ethanol to hydrogen? Oh, there is a lot of topics, no? As you know, today we are calling the e-fuels. E-fuels are the fuels that will be produced from these electricity surpluses that are more and more available in some countries in Europe, where they have a large capacity, an increasing capacity in wind power and also solar energy. And the dispatch of these power plants is done by God. It's not by the man who said, no, now we'll put this wind power to operate. No, it depends on the nature. Is the volatility is a problem on this. So in some times of during the night where there is almost no load in the electrical grid, we could be producing a lot of electricity. And this electricity could be used to produce hydrogen. And one way to use this hydrogen, to store this hydrogen, is to tie this hydrogen in some kind of molecule. And for instance, the ammonia or the ethanol are the usual carriers. Well, if you are developing a system to produce ethanol from electricity and CO2 in using the atmospheric gases to produce, why not to produce ethanol from the biomass in some conditions more competitive? Because if you are going to use surplus electricity, this surplus, to be more correct, it's not absolutely free. Such energy should pay some part of the capex of the investment. So I believe that using some systems that are producing hydrogen from ethanol, either in onboard systems by reform, catalytic reform, or again by catalytic reform in stationary places in gas stations, or to pump and compress it to use in cars, should deserve a lot of studies. What is the size of this equipment, the cost of this equipment, the conditions to well operate, how could be the load curve in different situations, different cases, assuming the penetration in different levels of use. It's very interesting. I think that is very possible that you are going to introduce faster hydrogen there than we are going to introduce electricity. It's fascinating to consider this future, but I do believe that we should explore more this duality of hydrogen and ethanol. There is a lot of synergies on this. The second question is also, again, around hydrogen and these sources of that are used in Europe as wind and solar, which are not dispatchable, are volatile, and it seems that in the forthcoming years the cost of this electricity will be, of course, increase, because someone should pay for that. If these electricity will be considered cheap or very free, someone who are paying more, because the load factor will be reduced. So I believe that there is some room for biofuels in this case. Are you hearing me? Okay. And
Yes.
and are you hearing me? Okay, because
Yes.
my
Yes.
screen stopped. Okay, so I believe that the potential of biofuels, sustainable biofuels, produced in competitive and sustainable ways, is large. Yesterday, in the discussion of the opening session of this BeBest, I heard, we heard from Fatih Birol saying that bioenergy is the overlooked giant because it's very more important than new fashioned wind and solar. It's easy to demonstrate that. So if competitivity is taken into account, economic competitivity, I think there is room for bioenergy in these contexts. We have other questions about the feedstock. Okay, the feedstock for hydrogen. I heard some, I saw, in fact, some studies about hydrogen produced from glycerin. As you know, glycerin is a byproduct of biodiesel production, could be used. There's different frontiers to be explored in terms of using this material. Of course, ethanol is easier, is cheaper, is very straightforward to introduce in the energy metrics in the transport system. I do believe that there is a large room, and I really don't understand why countries that has a large potential for bioenergy production are interested to use batteries, electric cars. It makes no sense. It makes no sense for me. It makes no economic sense. It makes no environmental sense. The lowest emitter, as I showed today, is a flexible hybrid car. If you are really committed to reduce emission, we should introduce this biofuel. If you are really looking for reduce greenhouse gas concentration. Okay. Finally, the question of biodiesel electricity. Again, biodiesel is another kind of biofuel. As you know, is not so cheap as ethanol is, but there is also a lot of side benefits in using biodiesel compared with electricity. And the fact is that we are going to introduce more and more diversity in energy for transport. If you are looking for buses and small distance loads and the small trucks, maybe there is open space for electricity. But surely, for a country as Brazil, considering the large distance and the trucks are moving agro produce and so on, is very difficult to understand that electricity could play a significant role. It's the role of biodiesel for sure. Glaucia, it's fascinating. Maybe we could take hours discussing that. It's just short bullets, may I say.
Thank you. All very interesting. I think we may come back to you at the end. I want to go now to Cassinelli. If he is here, can you speak, Cassinelli? Is everything okay with your
Yeah,
mic?
I'm here.
Okay,
Yeah, it's
great.
okay.
So I will read all the questions to you, and then we'll see how you can answer. The first question, are all the funds in the PIPES, PITES, and engineering centers refundable? The second question, could you please comment on PIPE and PITE projects, if possible, concerning the main practical limitations to get successful projects, and how would you encourage those willing to apply? And the last one is regarding Bioen, the perspectives of the Bioen program, considering consolidating universities, research institutions, and the industry in the area. How do you think we will be? What are our perspectives in consolidating the interaction between the different players?
Okay, I will start with the last one. I think is easy to answer. There are a lot of new technologies in this area of bioproduct. And I think inside the universities, a lot of people are working in development in new technologies to supply the new demand to avoid the oil-based products. I think that is very interesting to join the capacity to finance from state of São Paulo institution with universities and with the companies to develop the new technology. That is, I think, a way to incentivize to speed it up the new technologies. What's the next question, Glaucia, please?
Can you bring me back on? Can you hear me? Okay.
Yeah.
So the first question was regarding pitches, PIPES, and engineering centers refundable funds. Is it refundable, all funds?
No, just the PP is refundable. The other tools, just the counterpart from companies is required, like the part that company put inside during the finance project. Okay.
So only research in small business will have a phase that can be refundable.
Mm-hmm. Yeah, just
Okay.
this.
And the other one is the second question is it concerns the how to get to a successful project. What are the main practical limitations to be successful in a PIPE project?
The limited, good questions. I think it's a $1 million answer. I think that to be clear during the construction of project, I think is one point. To demonstrate the capability of group to develop the project, to have a good business case in the case of to request the pipe number 2 or 2.5, and if he is demonstrate the interest of third party to follow or to join in this program, I think is a way to prove that the project is accepted for the market. I think that's it, the main points.
Thank you, Cassinelli. We now try to go back to Heitor. Heitor, can you speak now?
Yes, can you hear me?
Okay, good, yes. Okay, so the question, you have two questions here. The first one You mentioned that 1 kilo of nitrogen used as fertilizer generates the equivalent of 10 kilos of CO2. Can you comment on strategies that are being used to reduce this impact? And the second question is, since the program is proposing the broadening of our feedstock basis, which do you think are the ones that most quickly could contribute to our matrix?
Well, the first question, half of these CO2 emissions come from the industrial phase of fertilizer production. So this is not something that we can work on, but the industry can work on. And these emissions come from the use of natural gas to produce ammonia. It generates a lot of CO2. The industry is working on solutions for that, improving procedures, and there's also a new thing going on is the what's called green ammonia. So instead of using natural gas, the industry is working on using electrolysis from wind or solar sources to produce hydrogen. And then this could decrease the CO2 footprint of fertilizer from the industry side. From our side, we can improve fertilizer use efficiency in the soil, producing more biomass with the same amount of nitrogen. And also, we can make use of some additives such as nitrification inhibitors that reduces the nitrous oxide emission when nitrogen fertilizers are applied to the soil. So there are several solutions. I'd say that the most practical is to increase the efficiency of nitrogen use in the agriculture and perhaps the use of nitrification inhibitors. But there are so different fronts to tackle this problem. Well, the second question about the feedstock to increase rapidly the bioenergy production, I think we are very well with sugarcane. We are progressing. Sugarcane production and ethanol production will increase. We have second generation ahead of us also. We are doing well with biodiesel, but I think one of the untapped sources of energy that we are not using here in Brazil is wastes. We have municipal solid wastes that can be transformed in biogas. We have vinasse, for instance, residue of the ethanol production. We have huge amounts of vinasse that today they are vinasse used as fertilizer, but before that we can make biogas and still use it as fertilizer. So I think there are several options. Wood, I think we have very good conditions to increase the production of wood to generate bioenergy in several ways. So I think we have very good opportunities here in São Paulo, in Brazil, to increase bioenergy using different feedstocks.
Okay. So thank you very much, Heitor. We now go to Rubens. Rubens, can you comment on how can biorefineries compete in the low oil fuels economy?
Yeah, that's a good point. That's a quite interesting point, and I believe that that's a point that you have to face always for time now. Once that we are going to have oil for long time, and as biofuels or new kinds of fuel for transportation is going to be used, we expect to have oil to be used in different ways. And then it can be for the petrochemical is one option. How it then can the biomass compete with that? I think if you look for the potential of biomass to produce new chemicals, and for particular use as in the biomedical area, cosmetic area, and some specific points that you cannot do with the oil-based chemicals. You can have a very large window of opportunities to work with the renewable material and feedstocks to produce bio-based chemicals, especially in the area of the for applications in the health areas, as well as in some kinds of applications that we are not able to do with the oil-based chemicals. For instance, uh, sometimes some of the building blocks, organic acids, come from oil. They have you cannot control the isomers, and then you have no control on the some any of use chemical or physical properties of the material. You can do this in a very sustainable way using bio-based chemicals. Then that's going to be a point that biorefinery is going to be very, very attractive and very strong as in business area, not only because it's green, but because it's offered the possibility to be sustainable and also to provide chemicals that are not possible to be done using the oil-based chemicals.
Okay. Thank you, Rubens. We now have a couple of questions that I think, well, there is one question here that was for Rubens, but I think I can comment. It is regarding research to develop sensors to monitor and control biofuels production. I want again to ask you to look into the list of startups that we have in the bioenfapes.org site. If you go to the research link, we have the list of RISP, Research in Small Business there, and half of them maybe are on the agronomical side. There's a lot of research on sensors for agriculture. They go they are being deployed in to solve many different questions in the field, in the mills. We have artificial intelligence. We have biosensors to detect contaminants, not only for biofuels, for cachaça as well. We have a lot of computation and informatics initiatives to speed up, decrease costs, and improve efficiencies in the whole process. So this area of sensors and artificial intelligence is really an area that is increasing a lot of modernizing a lot our bioenergy field. I want also to give the word once again to all members to comment on one question that was put here, which is what is the biggest barrier to the implementation of new technologies in the Brazilian agroenergetic sector? And I want to start by mentioning that one of the aspects that we felt was really hindering our efforts in transforming science in the lab into solutions in the industry is communication. We have been working with FAPESP, and we have been working with this with the niches, with the nuclei for transfer of innovation of technologies to the industry that we have in each university, and call your attention that we will have a session on this on the next BBES conference, a session to discuss specifically this theme with the niches from USP, UNICAMP, UNESP, UFSCar, in a session moderated by FAPESP, from Consaúde. So we are aware of this being a great challenge, and I'll pass now the word to my colleagues to comment on challenges that we may have to address. What is your feeling? What are your views on the barriers for technological implementation of solutions that we may arrive in the Bioen program? So first, can I give the word back to Rubens?
Yes, that's a quite interesting point. I do believe that we have to open our mind because many of the opportunities that you have in the bio-based chemicals using the biorefinery or biofuels, sometimes they conflict in terms of in economic terms of regular products coming from oil or a not renewable source. The point is, the society is not going to pay more only because it's cleaner or because it's greener. So the point is to develop a stable process that can be both good for the environment as well as a good business in the economic point of view. And this is not difficult to do with the price of the potential of the agribusiness in Brazil, especially sugarcane, soya bean, corn now, and the eucalyptus, and the urban waste, solid urban waste, as Heitor mentioned, that we are not doing a lot of things in this direction. The point is that we have to put in our mind that you have the potential, but not only the potential because it's cleaner or greener, but also because we have a very competitive price and technology with these long years of research in Bioen program to be implemented industrially. And the PIPE program, the PP program that Professor Cassinelli mentioned, that is one of the windows that can see how you can move from science to the technology. And the point is, Brazil has all the conditions to transform the biomass in more valuable products than you are doing now, maybe exporting too much and don't adding values to this produce, to this, let's say, feedstock that we have here. Even the agribusiness residues that are strong in biomass, which are very low price comparatively, and then the technology is not the barrier anymore, but only I see that we have to explore this opportunity with new products that are not to be faced with to be comparable with the oil-based chemicals. Return the word to Glaucia.
Okay, thank you very much. Horta, do you want to comment?
Yes. Thanks for this very challenging question. Maybe it's one of the most important questions. Okay, it's not just question of producing knowledge and data, but how to apply the conditions to reach the market in good conditions. In many aspects, biomass production is very site-specific, as you know, depending on the climate, the rainfall, the soil. Okay, we have a large potential, not only in Brazil, in Africa, in other neighbor countries here in Latin America, a large potential to producing biomass. And also related to the production of biomass is a little bit site-specific conditions to push systems to convert this biomass in bioproducts and biofuels and electricity. But why this large potential is still underdeveloped? Why we are accepting some models from other countries? Because in the case, for instance, in the transport, this is very clear. The schemes, the market constraints are defined not just inside our frontiers. It came from abroad. Okay, the design of the vehicles, the technology more pushed, more evaluated is not maybe our option. So I believe that as Glaucia start mentioning the communication. Okay, in fact, we are producing a lot of information. We need to diffuse more, to convince more people. But in some sense, I think that an important barrier is, in the case of Brazil, for instance, the limitation of our internal market regarding the potential of implementing this technology effectively abroad, where these bioenergy, sustainable bioenergy schemes should be also pushed, should be also promoted. So I think that one barrier to be overcome is the barrier of the dialogue, that we need to promote more integration, more discussion. So in Bioen, we are committed to do that. We are participating in some commissions in International Energy Agency. We are in GBEP, in FAO. We are trying to help Biofuture platform to go ahead to convince, okay, guys, electrical vehicles is so important. Other modern, may I say, modern power generation schemes is very interesting, but as IEA Audit Bureau said, bioenergy is the overlooked giant. You have an enormous potential untapped, and we need to show this in other markets, reach more balanced condition to push this. I said today that the vehicles in our roads today, the Corolla hybrid flex fuel, is the lowest, by far, the lowest emission car over the world. There is any other car emitting so low amount of GHG gases. Why this is not in news in other roads, in other cities, in other streets? Well, there is a lack of information. There is some barriers. There is some prejudice in many cases. We know how difficult it is still today to convince people that producing bioenergy doesn't harm food production. There is no slaves work in bioenergy production. So it's a kind of information to diffuse that is possible to produce sustainably, competitively bioenergy. It makes sense. It's good not just for Brazilian, it's good for mankind. Just Brazil will not able to make the revolution of bioenergy. We do need to spread this good idea in our neighbors in Africa and also in developing countries. They are absolutely interested to do that if they could understand the real advantage behind this energy source. Thanks.
Thank you very much. Now we give the word to Cassinelli. Can you talk about the biggest barrier to the implementation of new technologies?
Okay, thank you for all. I think that a way to grow a country is investing in technology. Here in Brazil, we have good opportunities to develop bioenergy from sugarcane, from other kinds of cultures, and we have the support from FAPESP. I would like to incentivize to use the three funds that I shown before: innovative research in small business program, partnership research in technological innovation, engineer reward center, research center. I would like to incentivize companies and researchers to use this kind of fund. Thank you.
Okay, thank you. Wonderful. Heitor.
Yeah, this is an interesting theme. We must say that not all research that we do in bioenergy is disruptive. Many times we do research that gives incremental results. We add to the knowledge that's available. This is the case for much of the research in agronomy, for instance, or in sustainability. Yeah, you cannot create a new company or a startup for that. So how do we implement this? With extension, good extension and good communication, as you said before. But there are lots of things that we do at the lab or at the field scale that are disruptive, are new, and can be transformed into new businesses. And I think the bottleneck here, I'd say that's education, because our generation has been trained to produce science and not look at the business side of what we produce. So we tend to replicate it with our students. And so we have to have a new mindset and to educate our students to the fact that they have an opportunity, and they must, when they start to work on their research programs, to, from the beginning, try to see the opportunities to develop new things and to start a new business. I think this is an important aspect, I'd say, education, to train the students and the new generation to think differently. That's what I'd say is one important bottleneck, in addition to the others that our colleagues have commented on.
Thank you, Heitor. And just to finish this topic, Rubens, there's one specific question on barriers for technological development here that regards 2G, advanced biofuels, lignocellulosic biofuels. Can you comment on the status of this, and what are the barriers that we still have to evolve through?
Yes, that's a good point, because I don't think that is not scientific barrier anymore. Some of part of the process, like the pre-treatment, suffer at the beginning of the, let's say, the first plant, some technological problem to deal with the behavior of the sugar cane bagasse in terms of the hydrodynamics of it, using in the treatment that led to use a lower amount of solid at the beginning, and this has been solved. Let's say that you can use now much higher load of solid, higher than 20-25%, compared to have at the beginning. Secondly, we have already the good domain of the process itself to the fermentation to go from ethanol from these hemicellulose fractions, and you can have the process itself splitting the two streams that we're going to go to the catalytic acid hydrolysis process. Then you have the C6 fraction that you can mix up with the sugarcane juice, and then you go to conventional process. So the process has already been solved in terms of its scientific and technological point. I believe that it is a part of the process. It's a learning curve that the process the cost tends to decrease with time, with the new plants that are coming, and then this has become more attractive because we increase the number of plants, then increase the amount of enzymes to be produced, to be used, and then it's natural to have a learning curve that leads to decrease significantly the price. This happens with the first generation ethanol, and for sure it's a matter of time that you're going to have the second G ethanol at your hands to be very, very competitive, and to adding to the first generation ethanol to become the market more, let's say, available in terms of ethanol production. And also, I would like just to add it to that the corn-based process that it has been introduced in the central part of Brazil, it's going to help in this direction because you increase the use, the period of the distinction production period of the plant. And if you see the process when you use the sugar cane ethanol, and then we use the corn based ethanol, which is very slight modification. You can go to second G, use more or less the same infrastructure. The point is the pretreatment, if it's well done, can be used in the sugarcane plant, first generation with sugarcane ethanol as well as in the corn-based ethanol. So I saw a bright future. I see a bright future for the second G in Brazil, and the scientific and technological point has been overcome already.
Okay, thank you. And now I answer one question here regarding plans and desires for international collaborations. I quickly mentioned one study that we are doing in collaboration with several countries, including India and Germany, to study emerging markets. So this we are organizing to meet the goals of this initiative work groups. Bioen, since its beginning, has organized work groups when we face those big challenges, such as it was when we decided to sequence the sugarcane genome. We started organizing a work group and inviting countries that were working on this field and some countries that were not working but had experience with crops to join us and define what were the best challenges. We also organized a work group on cellulosic ethanol many years ago. It made possible to seek for large funds, so we were able to fund several projects, including our National Science and Technology Center, INCT, for cellulosic ethanol. We had the CEPROBio project together with groups from the UK. We had a Horizon project, Horizon 2020, that was also derived from initiatives such as the organizing of these work groups. And we welcome partners that want to join us. We will seek, of course, new partners. And I have to tell you, we are very busy with the Bioen program nowadays, establishing all these collaborations, gathering data, and trying to do our job in increasing the impact of our publications. So these activities are very important for us because it increases our opportunities for dissemination of the lessons learned, of the good practices, of our good experience, and this learning curve that we have already we have gone through for so many years. And to finish, I want to answer one question here. The question is if Brazil is aware of, if we think that people in Brazil in general are aware of how clean our energy matrix is. And how important is this for the entire world as an example? I have to, again, mention Paulo Frankel and Fatih Birol, who yesterday gave excellent talks on this topic. Bioenergy is still considered the overlooked giant, not only in Brazil, but in several countries. We have been using biomass for bioenergy for millennia. Millions of years, but more recently we have evolved these technologies and we are using it at high efficiency, better efficiencies, and more economically compatible every year. It's incredible how much technology we have developed over the last decade. So we have to keep talking about it, and the answer is no. I don't think the population is aware of the riches that we have in this field and all the innovations and all the results that we have, the good science, but we are trying to, through BeBest and through other initiatives such as the BioFuture platform, our partner in this conference, to talk about it, to let people know that we are in a good trajectory. Thank you very much. I think we are reaching the end of our webinar here. I will, as I mentioned, post some links in Hoover for specific questions that were made, and you will also have available the slides from our presentations. Please visit bioenfapesp.org, our Facebook page. We are always putting news on papers and technologies that are derived from the program on the web. And I want to finish by thanking Heitor Cantarella, Rubens Maciel, Horta Nogueira, and Luiz Cassinelli, and also the backend team that helped us put together this webinar and all the sponsors of this conference. Thank you very much.
Quem tem uma empresa sabe quanto tempo é valioso. Por isso, a Apex Brasil apoia empresas brasileiras que querem exportar seus produtos, atrair investimentos estrangeiros ou empreender no exterior. Com a Apex Brasil, as empresas brasileiras têm um apoio estratégico para mandar seus produtos e serviços para fora do país de uma forma inteligente e segura. Com métodos inovadores, parcerias, soluções inteligentes, visão de mercado, conteúdos estratégicos e muita qualificação, a Apex Brasil é referência na promoção de exportações, internacionalização de empresas e atração de investimentos estrangeiros. A agência também atua de forma coordenada com atores públicos e privados em setores estratégicos, tanto para o desenvolvimento da competitividade das empresas quanto para o fortalecimento da economia brasileira. Se é conexão com o mundo de oportunidades no mercado internacional que a sua empresa procura, é o apoio da Apex Brasil que ela precisa. Acesse o mundo. Acesse Apex Brasil. Quem tem uma empresa sabe quanto tempo é valioso. Por isso, a Apex Brasil apoia empresas brasileiras que querem exportar seus produtos, atrair investimentos estrangeiros ou empreender no exterior. Com a Apex Brasil, as empresas brasileiras têm um apoio estratégico para mandar seus produtos e serviços para fora do país de uma forma inteligente e segura. Com métodos inovadores, parcerias, soluções inteligentes, visão de mercado, conteúdos estratégicos e muita qualificação, a Apex Brasil é referência na promoção de exportações, internacionalização de empresas e atração de investimentos estrangeiros. A agência também atua de forma coordenada com atores públicos e privados em setores estratégicos, tanto para o desenvolvimento da competitividade das empresas quanto para o fortalecimento da economia brasileira. Se é conexão com o mundo de oportunidades no mercado internacional que a sua empresa procura, é o apoio da Apex Brasil que ela precisa. Acesse o mundo. Acesse Apex Brasil.